So, very good afternoon to all the esteemed delegates. It's indeed my privilege to present this work in front of two former Secretary of Ministry of Steel. During the tenure of ma'am, this particular work was conceptualized and it reached its first successful breakthrough during the tenure of former Secretary of Steel, Mr. Sanjay Singh sir. So, it's a kind of a waste to wealth transformation, which we have carried out under a major sponsored research study funded by Ministry of Steel along with four major steel industries comprising ArcelorMittal Nippon Steel, Tata Steel, JSW Steel and Rashtriya Ispat Nigam Limited. So in India, around 19 million ton steel slag is produced as a solid waste annually, and this quantity is expected to reach 60 million ton by the end of 2030 with the expected augmentation in steel production in the country. At the same time, we are utilizing around 1.2 billion ton natural aggregate every year for the construction and maintenance of road network. So there is dearth of good quality natural aggregate, and acute scarcity has been faced by various national highway projects across India, particularly for the road construction and maintenance work. So like in an integrated steel plant, there are two major types of slag are generated. One is iron slag, which is commonly known as a blast furnace slag, and another one is steel slag. So blast furnace slag, after conversion into granulated blast furnace form, has found its very good utilization into cement manufacturing. But as far as the steel slag is concerned, its disposal has a very big challenges to the steel industry. For every ton of steel production, around 200 to 300 kg steel slag is generated as solid waste. Depending upon the type of furnace through which steel slag is generated, it can be further classified as a basic oxygen furnace or LD steel slag, electric arc furnace slag and the cone arc slag. So these are the three major routes through which steel slag are produced in an integrated steel plant. Besides that, like in a smaller steel industry, MSME sector, the steel slag is generated through the induction furnace route as well. So our major work is basically focused on the BOF, EAF and cone arc steel slag. So as such, the steel slag cannot be utilized for road construction. There are several intrinsic challenges which incorporate the volumetric expansion, which will be in the tune of 8 to 14% due to presence of free lime and magnesia. There is a vesicular structure. It is not as equivalent to the natural aggregate. There is the chances of tufa formation, chances of corrosion, as well as the heavy metal leaching. So what we did, we have developed the customized steel slag valorization technologies to convert different type of steel slag as processed steel slag aggregates for road making. And the last picture which you can see is a good quality processed angular steel slag aggregate, which is having even better physical and mechanical properties than conventional natural aggregate used for road construction work. After doing that, we get it constructed few steel slag road section across India, and the first steel slag road section was built in March 2022 at Surat Hazira. So this 1.2 kilometer 6-lane bituminous steel slag road is constructed using electric arc furnace steel slag of ArcelorMittal Nippon Steel plant, and around 1 lakh ton processed EAF steel slag aggregate were utilized as 100% substitute of natural aggregate in this road construction. So one of the novel feature of this road is that like the overall thickness of this road is around 32% less than the conventional road prescribed in Indian Road Congress guideline, which makes it around 40 to 42% economical than the conventional one, sir. The project which we accomplished is the NH66 Mumbai Goa. So on this particular section, we have utilized around 80,000 ton processed cone arc steel slag aggregate as 100% substitute of natural aggregate in cement concrete as well as bituminous slag road construction. And once again, there is around 28% thickness reduction in this particular project, which makes it 38% economical. And on this particular project, we have utilized this processed LD slag aggregate for construction of high altitude road. The major intention for the construction of this project is, so this particular project be completed in December 2022, and in this particular road, we utilize processed LD slag aggregate for the construction of bituminous surfacing. So the major intention was to construct this road is to have very high durable road under adverse climatic and high rainfall conditions. The conventional road at this particular location could not last for 3 to 4 years, but as per the study carried out by Border Road Organization, this surfacing is expected to have 10 to 12 year lifespan. So the Border Road Organization is working on a plan to utilize this particular technology for road construction in a longer way. The fourth section is NS33. So on this particular section, we utilize Tata Steel LD slag aggregate for the construction of 40 kilometer long section. But in this particular road, this slag aggregate was utilized only in granular layer. Not all the road layers were constructed using it. So the major benefit of the technology is that we can reduce the overall road thickness by 30 to 40%. Around 80,000 to 1 lakh ton natural aggregate can be saved by utilizing the industrial waste derived process steel slag aggregate in road construction. It's cost economical also. The overall construction cost can be reduced by 38 to 40%. It has higher durability of at least 4 to 5 times. It has negligible maintenance costs, and it also reduces the greenhouse gas emission in the atmosphere. Honorable Prime Minister of India has also appreciated our effort to the appreciation letter sent to CSIR by especially mentioning about these projects, and they have requested us to submit a 5-year vision plan to implement the steel slag road technology across India. We received a couple of awards for this sustainable initiative along with Tata Steel Managing Director. These are the different steel slag road projects which has been so far completed, and the few are which are underway. So with the Arjas Steel also we are constructing one steel slag road near Tadipatri on State Highway 234 with PWD Andhra Pradesh. That's all from my side. I have a small AV of 3 to 4 minutes. If ma'am permit, that I can run it quickly, sir. Yeah.
Iron and steel industry are pillars to a country's economic and infrastructure development. India produces about 110 million tons of steel annually and poised to achieve 300 million tons steel production by 2030. Along with steel, about 19 million tons of steel slag is generated every year during the refining process of steel from different steel plants situated across India. For every ton of steel produced, about 20% steel slag is generated. Most of the slag are dumped in the nearby areas of steel plants, which becomes the source of water, air, and land pollution. Steel slag, which is rich in iron content, can become the source of good quality steel slag aggregates for potential utilization as substitute of natural aggregates in road construction. In India, Surat has become the first city in the country to get a processed steel slag road built as part of a joint venture project between CSIR, Central Road Research Institute (CRRI), Union Ministry of Steel, Government Think Tank Niti Aayog, and ArcelorMittal Nippon Steel India at Hazira, Gujarat.
जब हम इंफ्रास्ट्रक्चर की बात करते हैं, तो अधिकतर लोगों के मन में पहली तस्वीर सड़कों या फ्लाईओवर की हो जाती है। ट्रांसपोर्ट इंफ्रास्ट्रक्चर के विकास पर आज भारत जितना काम कर रहा है, उतना पहले कभी नहीं हुआ।
And I believe that we must look at alternative forms of steel making, such as making steel from steel scrap, such as the example that we have seen of the 6-lane highway that was built with steel slag in Surat in Gujarat, the first of its kind in the world. And that happens only in India, made in India, ladies and gentlemen.
Or maybe India is now, today, formally entered into an era of steel roads. From concrete roads to steel roads, I think a matter of great celebration.
We have in the past pioneered in several new initiatives, one of which was the steel slag road technology, where we utilized the waste steel slag in road construction, highway construction very effectively and made it much more durable, in a way meeting the circular economy principle from waste to wealth.
कि जो रोड का निर्माण हो रहा है, जो धातु मल से स्लैग से, कॉस्ट वाइज भी अगर देखिएगा तो 32% 34% कम अभी है, और आगे अगर और रिसर्च होगा तो 40% तक पहुंच जाएगा। इसकी जो ताकत है, इसकी शक्ति है, वो भी जो हमारे और रोड बनाए जाते हैं उससे बेटर है।
I would like to congratulate CSIR CRRI for developing this innovative solution for utilization of processed steel slag in the construction of a steel slag road.
Research has shown the possibility of using steel slag in road infrastructures in order to promote the objectives set out by the Sustainable Development Goals to promote the circular economy and sustainable infrastructure. CSIR CRRI's innovative first steel slag road in Surat, Hazira has further motivated us our vision. For a greener India, for a sustainable India, for a rising India, Steel Slag Road. A sustainable green utilization of steel slag in road construction.